let's go ahead and get started. Again, you can kind of see here on the screen the variety of where people are visiting from. I looked a little earlier, and we have people from throughout our service area, parts of southeast Minnesota, northeast Iowa, and central and western Wisconsin, in addition to a few that have registered from around the country. So again, thanks for taking the time to join us here tonight. All right, again, hopefully you signed up tonight to hear and learn about lightning. Again, a very underrated danger, but it's important that we just know the dangers out there, know some of the safety tips, and I thought I would go over a little bit of how we monitor and the science that's involved with lightning here. Let's just start off by looking at this map is courtesy of a lightning company called Vesalia that keeps track of lightning strokes, if you will, and you can kind of see across the country over the last 5-6 years the density of lightning strikes. So fairly common here in the Midwest for lightning, and of course the deep South, and as you get into the eastern United States, Florida especially, with so many thunderstorms, and then certainly there is an occasional thunderstorms as you work your way west. But this gives you an idea of the frequency and again, just the threat level across the country. When we look at lightning fatalities and the climatology of it, lightning death, if you will, these are the total number of fatalities by year going back to 2006. And as you can see now, of course, I've got 2020 on there, so it looks a little skewed at this point. But you might be able to get a little feeling on these numbers that the trend, fortunately, with lightning fatalities at least, is coming down. The trend line, if you will, on these bars here is kind of working its way down, and that's good news. And we'll talk about that as we go through the presentation here tonight. When you look at lightning fatalities by month, I guess it's no surprise that the summer months, the warm season for us, if you will, are the prime lightning concerns. That's when we get the most thunderstorms, so it almost makes sense that as you go through the peak summer months, that's when we're at our biggest risk. As far as climatology by state, again, this is now back to 2009. You can see in parts of Minnesota, Iowa, Wisconsin, we have some occasional lightning fatalities, but the risk, because there are more lightning strokes, if you will, thunderstorms in the south and the southeast, it tends to be a little higher. When you look at some other climatology like fatalities, and unfortunately we see this with other thunderstorm hazards too, like flooding, it typically 2/3 to, in this case, almost 80% of the fatalities tend to be male. And then if we look at age, it's pretty skewed here, or I should say pretty widely distributed. But when we talk about lightning and outdoor activities, again, it makes sense that a lot of this would be teenagers all the way through the 50s or 60s, the more active years when people maybe spend a little more time outdoors in those age groups. So as we talked about, there's a lot of different lightning safety campaigns, and I just did a Google search, and you can see all the different graphics that are out there, all the different campaigns. In fact, later this month, there is a Lightning Safety Awareness Week where we try to spread the ideas of safety with regards to lightning. Now, the National Weather Service, of course, has campaigns on a variety of different thunderstorm hazards, but probably our biggest campaign is this When Thunder Roars, Go Indoors campaign. And the idea there, as we'll talk about tonight, is to stop activities and take safety. Now, this campaign and the push within the National Weather Service to promote lightning safety really kicked in gears in the 2000s. One of my counterparts up in Gray, Maine, the northeast part of the state, who's since now retired, John Jensensius, was key in promoting lightning safety. And ever since these campaigns got going, the number of fatalities has dropped 48% going back to 2001. So we've made great strides in getting the word out and pushing these safety ideas. But unfortunately, close calls continue. The picture in the upper left is at a Kid Rock concert And you can see the example on the bottom right at a halftime at a high school football game in Florida. Again, lots of close calls, and sometimes they're too close to call. There was a case in California where just a passing weak thunderstorm struck someone on the beach, and more recently, I believe last year, in Georgia at a PGA championship, lightning hit a tree where there was all kinds of people gathered, and there were lots of injuries. So unfortunately, there are still these incidences, even though we are promoting, of course, lightning safety. Now, medical concerns with lightning is something we'll talk about tonight, and certainly a concern, but realize that lightning also has other dangers in a sense of occasionally we do hear about house fires. In fact, we just had a case in the past week or two in Rochester, Minnesota, within our office's service area of, I believe, an apartment complex that started on fire from a suspected lightning strike. But wildfires out west are sometimes the cause from lightning, tree damage, and we hear about the cases of cattle getting struck. So there are these other, dangers from lightning, certainly. All right. If you're interested in taking some of these interactive polls, I have my first, or I should say second question for the night. We're going to talk about how lightning forms. So before we do that, what direction do you think lightning travels? Does it travel from the cloud to the ground or down? Does it travel upward from the ground to the cloud? Or does it possibly travel in both directions? So we've got A, B, and C here. We'll see what you have to say here. And yeah, it looks like we got a little bit of voting kind of in all categories here, but the majority is correct there with both up and down. And we'll talk about that, but oftentimes lightning kind of meets in the middle, if you will, or there's a connection made. So yeah, it's good to know that it's not just always a cloud to ground. All right, so how does lightning form? It's kind of a complicated process, but it basically comes down to as the ice and the air move around in storm clouds, and there's a lot of movement. With thunderstorms, you're probably all experienced gusts of wind from thunderstorms, and here the last couple of days we had wind from even a tropical storm system. But the bottom line with lightning is when you have ice moving around in the clouds, the air movement, it tends to separate the charges, and a lot of times we'll get negative charges building up towards the cloud bottoms and a positive charge towards the cloud tops, especially these taller thunderstorms. So it's almost like the clouds out there as they form, if they get enough of this ice interaction and these charges building, the clouds almost become a battery. And at the same time, you start building charges along the ground. So I've got a little bit of a different animation here, just kind of showing you how these charges, if you will, can work their way down from a thunderstorm cloud. And at the same time, in the picture here kind of shows you an exact image of it. Sometimes there is what we call step leaders, or these charges that are building up from terrestrial objects or objects on the ground, like trees and tops of buildings and things like that. And of course, when that connection is made, and it's fairly random if you think about it, once that connection is made, there is that discharge of the battery, if you will, or the cloud that is above or near your location. So there's a lot of interesting videos out there. You can look online and just look for like super slow motion lightning strikes. I have a couple here to show you. Now these are slowed down, I don't know, 50,000 times. So now we're talking about milliseconds here slowed down in this video. It kind of shows you how these charges, you don't really see the charges from the ground in this particular example too much, but it does demonstrate the randomness of lightning as these channels work through the sky and eventually make a connection and discharge the stroke, if you will. So pretty fascinating to see the randomness of it and how one channel just kind of opens up. All right, got another little segment of video here, kind of the same thing, very slow motion, and you can hopefully see the different charges working their way to the ground, and once they meet, they discharge the voltage that has built up, the charge that has built up. So when we talk about safety, again, that's one of the concerns with lightning is the sheer randomness of it. I mean, yes, you have to have a thunderstorm around, but the fact that you don't exactly know when and where is a key safety factor, and we'll get into that. Now, when it comes to types of lightning, this is kind of a more technical, complicated slide, but it just kind of shows you the different variety, if you will. Different types of lightning. Sometimes we get ribbons of lightning and within cloud lightning. In another example, this slide kind of shows you the charges throughout the different cloud layers that sometimes lead to these lightning strikes and the different types of lightning out there. You know, there's cloud to air, there's cloud to cloud, there's within cloud. And then, you know, the danger ones for us, certainly, when we talk about safety, we're very concerned with that cloud to ground lightning strikes, especially, again, when people are outdoors. Now, a lot of times people ask about heat lightning or what is, you know, heat lightning. And really the bottom line for what heat lightning is it's nothing more than a distant thunderstorm. So on a given evening, you know, you might see these flashes off in the distance, and the lightning isn't forming from just the sheer heat out there. It's forming in a thunderstorm that's just a distance away, sometimes a long distance, depending on where you live in the country. I think one of the reasons it got its name heat lightning is because typically thunderstorms will form at night or in the evening when you get into a very warm or hot evening, you know, with that fuel for the thunderstorms. And so the idea of heat lightning is, again, you'll see those flashes way off in the distance from a distant thunderstorm. Now, kind of funny how we go from the phrase heat lightning to just let's talk about the temperature of lightning. And I found this graphic from one of our neighboring national, or not neighboring, but one of our fellow National Weather Service offices down in Florida, the Melbourne office, talking about the temperature of the sun. So you talk about, and of course, the temperature of lightning. The average temperature of the surface of the sun is, you know, roughly 10,000 Fahrenheit, but the actual temperature of a channel of lightning is 5 times that. So, you know, we talk about voltage and amps in lightning. There's also a lot of heat. And while burns from lightning victims aren't always the thing that kill them, it's oftentimes the electrical part of it. People often do get burned, you know, from these extreme temperatures out there. And it's another reason why sometimes trees, when they're struck, die or they explode. Or again, so there's a lot of power with lightning, certainly. And the lightning strokes, if you will, or channels of lightning can also be very long and tall. Depending on where that lightning strike occurs from the storm, it could be several miles in length. But even through that, believe it or not, these channels that open up are very narrow. Most researchers think that lightning is no more than the diameter of a quarter. So you're talking about, you know, a very intense flash and a long distance there, but the actual diameter of a lightning strike is very narrow, about the size of a coin there. All right, so how do we, in the weather business, if you will, and it's not just the National Weather Service, but private meteorologists, broadcast meteorologists, how do we monitor lightning? Well, believe it or not, in the National Weather Service, we actually do not have our own lightning network, if you will, but there is companies that we share lightning information from, and there is a network of ground sensors throughout the country that help us detect lightning that is out there. And so we have ways to overlay lightning strikes over our radar imagery, as you can see in some of these cases. There are some private web pages that you can go to and look at lightning strikes, albeit a lot of times those are maybe delayed a little bit in their lightning plotting. And then these days, kind of new technology and kind of exciting for us as meteorologists is the enhancements that are coming to us from satellite technology. So some of these newer satellites that we've had access to the last couple of years can now track lightning flashes, and in some cases, these flashes that can carry, you know, tens of hundreds of miles in one lightning strike, we can detect from satellite. So I just wanted to show you, these are kind of technical slides here, but just different views that we at the National Weather Service we can monitor storms, of course, with radar and put the lightning strikes on there, but we can also look at how the satellites are picking up these flashes and how far into the, let's say, the tops of the thunderstorms these lightning flashes are carrying. This really can help us give people advance notice when we are helping county or event planners that have maybe a festival going on or anything like that. We can give them better idea of how far lightning is extending from these storms. So there's a lot of uses for these ways that we now monitor lightning. And one last set of animations here, just kind of showing you the different views that we can look at the tops of thunderstorms now from space and kind of get an idea, combined with what information we get on the ground, to kind of get a feel for how far these flashes are going. So new stuff. It's pretty exciting that we can use that, again, to give people some advance notice these days. All right, let's shift gears a little bit now and just kind of focus on the safety aspects of it and talk about some preparedness ideas. So when it comes to people getting struck by lightning, believe it or not, 90% of lightning victims do survive. So, I guess if there is some good news, there it is. But the problem is most people that have gotten struck continue to have neurological problems for years after. And in some cases, I talked about before, severe burns. A lot of times the fatalities that do occur from cardiac arrest. So it's basically how the electricity is impacting the heart and the body system, if you will. It is interesting from some of the medical information, believe it or not, serious burns are actually more seldom with lightning strikes than you might think. All right, so another poll question for you here if you're taking part in it. Have you ever had a close call with a lightning strike? Have you ever had a lightning strike very close or kind of took you by surprise? You can answer B if yes, and of course A if no. All right. Well, it may be no surprise that if you have had some close calls with lightning, that you might have interest in this subject. So 80% or 8 out of 10 of you here tonight have had close calls. So that's pretty scary. Some of you have been fortunate enough not to, but that's why we're going to talk about some of the safety tips here. I myself too have had a close call. I was visiting a relative once with one of my family members out in a farm in South Dakota. A teenager at the time, maybe didn't know the best at the time, and lightning struck the main yard light. And we were probably only about 15 yards away. And while I wasn't injured, it sure got my attention, that's for sure. All right, so I am not certainly a doctor, but when it comes to medical symptoms that happen right away with lightning survivors, is you hear stories about muscle soreness. You hear survivor stories about headaches, nausea, upset stomachs, and things that are very related to post-concussion symptoms. Mild confusion, memory slowness, dizziness, balance problems. I always like to think about, if you think about how the brain works and how the electrical charges that take place in the brain, and you think about getting hit by lightning and how that could damage some of that. And so there is, again, a lot of neurological problems typically. Now, more longer term effects or more serious effects sometimes can happen with survivors. And I'm not going to go read through all of these, but it talks about problems multitasking, slower reaction times, personality changes, serious headaches, chronic pains, all kinds of things, again, that are oftentimes neurologic. And it can go on from there, difficulty carrying on conversations, depressions, all different types of levels of symptoms there. So again, that's even if you survive, there is a lot of reason to be cautious about lightning risks out there. So have you ever stopped and think, am I safe? Am I safe doing what I'm doing? I'm watching my kids at their softball game, or I'm at a concert, and I know 2020 there might not be a lot of concerts. Am I safe being outdoors, doing some yard activity, mowing the lawn, riding the motorcycle, things like that. Again, if you're not thinking about these hazards or aware of them, that's when people get themselves in a bad situation. And you can see some of the, hopefully you can see some of the video here and some of these examples. Now, a lot of times I've heard, people that hike, especially in the Western United States, or maybe you're a fisherman, or people are outdoors and they'll get these sensations of their hair standing up on end, or and their skin getting tingling. And these are some photos of people hiking, and you can see how their hair is standing up. Think about what's happening in these cases. This is happening because there is literally static charge building up, or a charge building up on them through the ground, and at the same time probably thunderstorms above them. Here's another case, and this story is very interesting, with a family outing, a couple families, and they're hiking. I believe this was taken in North Carolina, and they thought it was kind of cool. There was some showers around, but they took this picture and all their hair was standing up on end. And then they realized right when they were doing this that maybe there was a lightning risk. And sure enough, there was a lightning strike, maybe the next hill over or stuff. They did survive, but didn't realize it at the time that they could actually tell that lightning charge was building up around them. So those are all danger signs to certainly move. So when we talk about lightning safety, I don't think it's any surprise, but you're most at risk when thunderstorms are near. So if you know there are storms around, that sort of thing, you're most at risk. You're also more at risk when you're near tall objects, towers, things like that, or in a high or open areas. Like if you're hiking on a ridge top, in an open field, body of water, or maybe even near trees, things like that. We'll get into more details there, but hills, lakes, things like that. If you're the tallest object out there or near something that is very tall like that, you are more at risk. So look at activities of lightning fatalities. Again, getting back to some of the climatology that we have here. This is for cases from 2006 through 2019. You can see that there's a percentage of people that were doing work-related activities or doing daily routine activities. That might be mowing the lawn, sweeping outside, that sort of thing. But almost 2/3 of the activities are leisure. So these would be, things like hiking, golfing, swimming, things like that. So you can see how that's kind of broken down. And what I did was I went back through 2006 and tried to define the case, the activity, the matching word, if you will, for when people lost their lives from lightning, and made a little word cloud about it. And so you can kind of see how the bigger the word is, the more instances of that cause. And so, again, construction, being on the beach, fishing, working, running, walking, hiking, those are all things, that have led to lightning fatalities. So you can kind of get the idea here. All right, another question for you here then. Where is a safer place to go when lightning is around? I don't know if there's always a completely safe, but where is a safer place to go when lightning is around? So of these 5 options that I put here, to a park shelter, under a tree, indoors, maybe in a ditch, under a tent, what is the safer place to go when lightning is around? Give you a little bit longer here if you're thinking about it. If you're with your kids tonight, maybe ask them, see what they think. All right, looks like the voting is kind of slowing down there. Yeah, I mean, we'll talk about these different cases, but certainly indoors is the number one rule of thumb. I mean, that is the safest place to go anytime there is a lightning risk. So if you don't get anything else from the presentation here tonight, number one rule is move indoors. Move indoors anytime there is lightning activity in the area. So when you think about where is the safest place versus the least safest, you kind of have to think of it as kind of a spectrum, if you will. Certainly the safer locations in a sturdy building, right? In a house, in a building, school, any kind of well-built, protected structure is going to be safer from lightning. So those are all safe locations. A hard-topped car, certainly safer as well. But may not realize it, but less safe or non-safe locations might involve convertibles, bicycles, being on a motorcycle. And yes, there have been cases with bicyclists and motorcycles getting struck by lightning. And then it kind of goes down from there too. Chain link fences, golfing, being near trees, uh, bleachers, near towers, things like that. They're all not as safe, right? Those are all either places that can attract a lightning strike or spread it across a large area and maybe injure a lot of people at once. So again, those are far less safe. So if you remember right, I talked about this spectrum, if you will, from less safe to more safe. So, the less safe locations, being outdoors on a hill, hiking on a mountaintop, things like that, by far the worst case scenario. But then as you get in, park shelter, yes, there is a rooftop, but you don't have any walls there. Car is, much safer, but as you get towards, again, a well-built home structure, things like that, that is more safe. Now, it's not just important to know what type of structure you're seeking cover from, but there's also this risk at different distances from that lightning strike, right? Distances from that thunderstorm. So, 20 miles away is considered pretty safe from lightning. It's pretty rare that anything would go that far. But obviously, if the thunderstorm is overhead, you're going to be at the highest risk or the least safe. And then, of course, as you go distance from there, yes, your safety factor goes up a little bit. A lot of the new rules out there is what's called the 30-minute rule. In other words, waiting 30 minutes before you head back outdoors after the last time there was a rumble of thunder. But a lot of the events that we work with these days, they're kind of looking at an 8-mile distance too, as where it starts to get safer. Within 8 miles, you're at a risk, and again, that risk is higher as the thunderstorm is closer. So kind of judging your distance sometimes can be a factor too. And one way to do that, of course, is to, if you see the lightning strike, just start counting seconds. And for every 5 seconds you count, that's approximately, or that lightning was approximately 1 mile away. So you see a lightning strike, you start counting in seconds, and once you hear the thunder, every 5 seconds of that time has passed, that is 1 mile away. So you see lightning, you count, you get up to 10, and then you hear the thunder. The lightning strike was approximately 2 miles away. So that's one way to judge. Now, one thing to remember, though, is sound does dissipate as it travels away from the storm. So when you get, a distance away, you might not be able to hear the thunder. That can sometimes vary depending on the heights of the clouds. And of course, with heat lightning, for example, it's usually way too far away, so you would never hear any thunder that far away. So when you talk about when do I need to go indoors, when do I need, think about, are storms expected? Was there a prediction of thunderstorms out there? I've been at events living in the La Crosse area here where, yes, there were thunderstorms expected. You can see them coming in on radar. And I've seen events continue on, even though you can see lightning off in the distance. That's not a safe situation at all. Are you in an area that's more prone to lightning? If you're hiking and there's dark skies around, you hear some rumbles of thunder, again, you're at maybe an area that's more prone to lightning. Are skies darkening? Are the storms building, or is there storms approaching? And of course, do you see lightning? Remember, though, there always has to be a first strike, right? So you have to be a little careful there. If storms are still forming over the area, and there's a prediction of thunderstorms for perhaps, you got to realize that there always is that first strike. So ultimately, when we talk about our number one safety rules here, no place outside is safe when thunderstorms are in the area. So once you start hearing thunder, like we talked about, if you know there's storms coming, lightning is close enough to strike you, and you should immediately move to a safe shelter. Now, again, depending on where you're at, you have to kind of weigh those risks. Being at a park and there's no buildings around, the car might be the safer location, of course, versus standing under a tree or under a shelter. But if you can get to a structure or building, that is, of course, safer. And then I talked about but stay in that place of shelter for about 30 minutes typically after you hear the last sound of thunder. And that's assuming that those storms are moving away from your location. If there's storms continuously kind of reforming in your area, then you might have to start that clock over or just find a different time to go outdoors. All right, before we kind of finish up here, then let's just cover a few lightning myths. And there's a lot of different lightning myths, so I didn't want to go through them all tonight, but just some common ones that come up. Like lightning never strikes the same place twice, right? No way. Lightning is so random, right? It has to always be in different locations. If your tree was hit once, no way could it get hit again, right? Well, actually, that's very false, right? Lightning oftentimes does strike the same place twice. It'll strike towers. You can see some of the animations here. Of course, tall buildings in large cities are very commonly struck. Trees around the area might be struck. Poles, things like that. I mean, typically higher areas do get struck. Our Doppler radar at the Crosse National Weather Service is up on a ridgetop in the area here, up on one of the bluffs, and it's been struck many times. We have it grounded so we can stay operational, but lightning does oftentimes strike the same place twice. All right, how about this myth? I don't know if this is a true myth, but this maybe misunderstanding that the reason your car protects you from lightning is because of the rubber tires. That the rubber tires actually insulate you from the ground, and so it keeps you safe in a thunderstorm. Well, that's not entirely true. Really, what happens is the shield of the car kind of protects you. It acts as a way to kind of move that charge, that lightning around you, and sometimes yes, it does go out through the tires, but it might jump from the body of the car down to the ground too. But it's more of the metal shield that the car provides you than the rubber tires. And so if you are in your car during a lot of electrical activity, you definitely kind of want to keep your arms away from the side of the car, from the door, maybe, kind of sit in the middle just in case. All right, how about this myth? If it's not raining out or there aren't any clouds overhead, you're safe, right? There's no chance of lightning. It has to be downpouring, right, to get lightning. Well, again, this is a myth. This is a definite falsehood. If you've ever heard the phrase "bolt out of the blue," then you kind of know what we're talking about here. Lightning can travel quite a distance, as we talked about, and there are phenomenons where charges from the tops of thunderstorms can actually discharge to the ground, and oftentimes those are much more powerful strokes of lightning. They can actually be far more dangerous and cause more property damage too. So you don't always have to be where it's raining heaviest to get struck by lightning. And again, distance factor in, so be alert for that. All right, this is a very common myth. If you're caught outside during a thunderstorm, you should crouch or lay down to reduce your risk of being struck. What do you think on this one? Now, I will admit, for a lot of years, the National Weather Service and lightning experts and stuff recommended that you crouch down, get in a low area and actually crouch down. I don't know if the idea of laying down has been out there for quite a while, because that's putting yourself at more contact with the ground. But in more recent years, lightning experts and us, the National Weather Service, are trying to get away from this idea of just crouching down. Really, your best rule of thumb here is to find a place of shelter. Again, hopefully you know that there's storms out there. Some of the lightning preparedness videos that we share within the National Weather Service talk about, you might be hiking, you might be enjoying the day, but you see some thunderstorms building, it starts to look dark, maybe some rumbling. Boy, that's the time to just get out of there. That's the time to exit your trail, whatever, and get to a place of shelter. So really, just getting to shelter is what we recommend. Now, doing some of the research for tonight, I stumbled across this slide, how to survive a lightning strike. And I won't read all the text on here by any means, but I thought it was kind of funny, the bottom left there. This is from The Art of Manliness, which might explain why, almost 80% of the lightning fatalities are men. So, and hopefully smarter than that. All right. Another myth here. Tornadoes are far more dangerous than lightning. Is that true or false? Is that just a myth? So actually, lightning is just as dangerous as tornadoes. Now, yes, there are years when the number of tornado fatalities is fairly high. 2011 was a very bad year for tornadoes in the United States. But if you look at the average number of fatalities, it's oftentimes higher with things like lightning or flooding than it ever is tornadoes. And I know in the La Crosse area here, in our service area that kind of encompasses the region here, we've had more problems from flooding. We've had more problems from lightning, even dense fog, than we have with tornado fatalities. Now, I always knock on wood when I say that, but again, lightning is a danger that is out there with every thunderstorm. So it should be, the threat should be taken seriously. And I think the last myth I have for you here tonight is I'm completely safe when I'm inside. Well, you're definitely safer, and in most cases you're safe, but I don't know if I'd say completely. So I guess if you really get down to it, staying away from electrical equipment, not leaning on and walls, maybe not taking showers or using the plumbing system. Corded phones can still be a danger, things like that. Just, if you have a lot of lightning activity around your house or where you're at the time, just some simple rules there. Stay more indoors, inside the structure, away from windows, and be alert for that possible electrical or lightning risk that is out there. All right. I think this might be the last poll question we have here. We're almost done here, but how about this question, just out of curiosity? What do you think on this? The National Weather Service issues warnings for lightning activity. Would you say yes, B, no, or you can answer C this time for not sure, if you're not sure. I'll give you a second here to talk it over or decide what you think here. And does the National Weather Service issue warnings for lightning activity? All right. Got a few votes in there. It's kind of all over the place, but believe it or not, in this case, the National Weather Service, we do not issue official warnings for lightning activity. Yes, we have official warnings for things like tornadoes, flash floods, severe thunderstorms, heat, if you will, but we don't actually have any warnings for lightning activity. Sometimes we will try to spread the word that there is a lot of lightning with storms, and it's certainly a danger we talk about. But the point here of this little poll question is you could have a thunderstorm passing through the region, and there's no large hail, there's no damaging wind, no tornadoes, and so we at the National Weather Service don't even have warnings out on it. It still poses a danger, right? If it's producing lightning, there is that danger there. All right, just a few fun facts for those of you that kind of the frequently asked questions, if you will. Sometimes they talk about when lightning hits a lake or the ocean, how come all the fish don't die? If electricity and water don't mix, why is that? Well, when you kind of look at this map here, this global map, you can see that lightning strikes are just not as common over the oceans. So that's one factor. But maybe more importantly is there is this phenomenon called the skin effect, if you will. And what happens is when lightning hits a lake or a body of water, a lot of times the charge is kind of diffused along the skin, if you will. It has a way of trying to ground itself or spread out through the best way it can conduct. And a lot of times that's just the very surface of the water. And that's why typically you don't have a lot of fish killed or anything like that. Also, when you talk about how much voltage is in a lightning strike, well, lightning strikes oftentimes can produce 300 million volts, maybe on the order of 30,000 amps, whereas your home outlet 120 volts and 15 amps. So we're certainly talking about a lot of amps and voltage there. And then we talked a little bit about how the car shields you from lightning, but sometimes people talk about, well, aren't airplanes struck by lightning a lot? And yeah, it does happen occasionally. But again, the lightning usually will pass through. There's typically not problems with aircraft, but from the little research that I've done on it, typically if an aircraft, especially a commercial aircraft, suspects that they were struck by lightning in flight, maybe even landing or taking off, then that airplane is typically inspected just in case. But people are usually safe, of course, flying through those. All right, to kind of finish up then, there's all kinds of lightning information out there. The National Weather Service, if you go to our main webpage and look for the safety ideas, or you just go to weather.gov/safety/lightning, you'll be able to see a lot of information on there. You can keep up with statistics of lightning injuries and fatalities. Again, this year so far, we've had 3 fatalities, all doing outdoor activities. And then there's another nice site called lightningsafetycouncil.org. Again, Lightning Safety Council has a lot of great information, and again, stats, maps, things like that. So we kind of work together with these groups. One last thing I wanted to mention tonight is just if we talk about spelling of lightning, just kind of bring it up. Lightning is spelled with an N-I-N-G, and realize that lightening is something different and lighting is something different. So we'll do a little spelling lesson here, but lightning is spelled L-I-G-H-N-I-N-G. So all right, that is all we have for you here tonight. Again, I really appreciate you taking the time here